All right. Well, hello, everyone. Thanks for all of you who are joining us today. My name is Dalia Spasova. I'm part of the developer marketing team here at Kong, and I'd like to welcome you all to our February Kong Gateway online user call. Today, we have a very special presentation for you from Michał Flendrich, who is a staff engineer here at Kong. Michał is going to talk to us about the latest update to the Kong Ingress Controller version 2.2, which includes our initial implementation of the Kubernetes Gateway API. And at the end of the presentation, we will open it up for Q&A and discussion. You will also be able to unmute yourself, turn your video on, ask questions, but also please feel free to drop your questions in the chat at the bottom of your screen. And yeah, we will answer those at the end. And so with that, I would like to hand it over to Michał to start the presentation.
Thank you, Dalia, for introduction. Thanks everyone for joining. Good morning, good afternoon, good evening, wherever you're joining from. Yeah, I'm excited to be here to give you a sneak peek into the releases 2.2 and 2.3 of Kubernetes Ingress Controller that are out right now. I'll talk a little bit more about the highlight of the release, which is our technical preview of the Gateway API implementation. The 2.3 version, like this presentation, encompasses both 2.2 and 2.3 because 2.3 was released only a few days back. And yeah, we thought it would make sense to include the recent developments in this presentation as well. So for a bit of an introduction, my name is Michał Flendrich. I'm a software engineer at Kong on the Kubernetes team. Today, my teammate Shane Att, who is also a software engineer on the Kubernetes team, is with me. He will help me answering your questions regarding anything Kubernetes or Gateway API. Yeah, so 4 words of personal info. When I'm not at my keyboard reading through the bug tracker or email or code or typing code, I go cycling on my road bike or hiking. On the picture, you can see myself and my 4-legged barking companion with the pointed ears, which detect every slightest noise in the corridor and driving my neighbors crazy with his barking. So if you hear fur during this presentation in the background, you'll know what I'm talking about. So yeah, for a bit of an overview of this presentation, like I said, we're going to get you familiar with 2.2 and 2.3 releases of the Kong Ingress Controller. Like I said, the highlight of these 2 releases is the technical preview of Gateway API support. In this presentation, I'll give you a very brief demo of what Gateway API means in Kong, and we'll go into a little bit of detail as to why Gateway API is such a breakthrough for Kong Ingress Controller and what possibilities it opens now and in the future. Yeah, so unmanaged and managed gateways are a specific detail, which is somewhat important, and I would like to devote a bit of attention to that. And we'll go into a little bit of detail as to the near-term and somewhat long-term roadmap for the Kong Ingress Controller. Okay, so first, like I said, the highlight of the 2.2 and 2.3 releases of the Ingress Controller is the technical preview level support for Gateway API. Users of Kubernetes know that the Ingress API has been the gold standard for defining how traffic from the outside of the cluster will be able to reach applications running in a Kubernetes cluster. The Ingress API is with Kubernetes since virtually the beginning. And that Ingress API has some problems. One of the problems is that the Ingress API is quite tightly coupled with several details and is very much opinionated about the protocols it configures. To be more specific, the Ingress API is HTTP-centric. Gateway API is a recent effort by the Kubernetes special interest group SIG network. It's a modern set of APIs for deploying not only HTTP, but a wider variety of exposing a wider variety of protocols. such as TCP, TLS tunnels, UDP, and virtually everything, because the API is designed in such a way so as to be extensible for supported protocols. We'll drill a little bit deeper into that later in the presentation. Yeah, like I said, the version 2.2 of Kong Ingress Controller introduces Gateway API support as a technical preview. When I say technical preview here, what I mean is that this is a phase of the development where we think that it's appropriate for early adopters to try using this new API with Kong Ingress Controller. As we collect feedback from those early adopters and people who are interested in this new API, we'll be incorporating that feedback into further steps of graduation towards general availability. This feature being a technical preview means that it's currently hidden behind a feature flag. So in order to use Gateway API in the Kong Ingress Controller, you need to toggle the feature flag by saying gateway equals true in an environment variable that you set in the Kong Ingress Controller. I have done that in the demo environment, which I'm going to show you in a second. If you want to do this yourself, when you're running the Kong Ingress Controller, you can just follow the using Gateway API guides on Kong docs, which the link to will be shared alongside the slides. So the golden rule of live demos is that something always breaks. Let's hope that's not the case for us today. I would like to show you how I install a Gateway API in a cluster, then deploy the Kong Ingress Controller with Gateway API support, and I will show you how to expose an HTTP and UDP service by means of Gateway API. So for the purpose of this demo, I have prepared a micro Kubernetes cluster, micro-KS. I'm running version 122, if I'm not mistaken. Yes, it's 122 server. What we're going to do is go to the examples directory of the Kong Ingress Controller repository. And here, if we look into gateway HTTP route.yaml, we can see that in order for us to be able to use Gateway API, we need to install Gateway API CRDs. So these are definitions for types which are necessary for Gateway API to function, which I'll give an overview of in a minute. They are set to be included into core Kubernetes at some point in time, but for the time being, since Gateway API is an emerging technology, they need to be installed manually. And this command, which is here in the comment, performs that. So let me maybe so let's do that. Okay, I'm using a shell that requires me to quote this. So what's happening right now is that the Gateway API, see how these are being installed, downloaded from the GitHub repository of the Kubernetes SIG. Okay, you can see they have been applied to the cluster. So now, next step we can perform is go to the example manifests that you can use to install the Kong Ingress Controller. We have made some tweaks to the examples that have been that not normally ship with Kik, which I will go through real quick. So, for the purpose of this demo, I have taken the stock file that tells Kubernetes how to deploy the Kong Ingress Controller and made several changes. So first, I have added a UDP listener because we're going to I'm going to show you how to set up a UDP service using Gateway API. In order for that to happen, Kong needs to be aware, like Kong needs to be configured with a listener for UDP on port 53. The way it's done here is that the Kong container exposes a high port 53, so as not to need the root privileges for that, and an appropriate port mapping happens, which makes it like together with service configured this way, it makes the whole thing work on port 53 from the outside of the Kubernetes service without the need to open open a low port on the Kong container. So this is an implementation detail. We have changed the type of the default service from load balancer to cluster IP because the the Kubernetes cluster that I'm using doesn't use any load balancer, so we're just deploying the Ingress controller in a standalone fashion there, so we don't need a load balancer. And the third change we have is the aforementioned feature gate. Basically, we're enabling the technical preview of the gateway API support by means of this feature gate. So let's apply it. What's happening now is that Kong Ingress Controller is being started in my Kubernetes cluster. It takes a couple of seconds for the Ingress Controller to spin up. Let's see. Okay, the service is already up. Its cluster IP is like this. So if we make an HTTP request to this service, we should get a response from Kong, which is going to be a 404, meaning that Kong is up and running, but no route or no proxying rule has been configured for the /path. Okay. And let's see why.
You're hitting the pod IP or the service IP. It's not a load balancer.
That's right. So we're looking at the cluster IP, so I should be able to access the cluster IP directly. This is how micro Kubernetes does this. Okay, so now it works. It seems that it took a couple of seconds for the Kong pod to spin up, but now Kong is up and running, so we can see this is a 404 message. If we run the purpose mode of serial, we can see that the response is indeed 404. This means that Kong has properly processed the request, but does not have a matching route yet. So the next step of the demo, now that we have Kong up and running and ready to handle Gateway API, we're going to go to one of the examples which are bundled with the Kong Ingress Controller and see how to deploy an HTTP route with Gateway API. So what happens in this demo is that we deploy a very simple example service, which is called HTTP bin. So for those who don't know HTTP bin, this is a Swiss Army knife of a kind that deploys an HTTP service that you can run and query in a variety of ways in order to test various request methods, various response types and things like that. So we're just going to use it as a placeholder HTTP service that will route the traffic to. Yeah, so here is where the interesting stuff about Gateway API is. So something that I will quickly pitch later in the presentation is that one of the notable gains from Gateway API is that before Gateway API, it was the sole responsibility of the API gateway to manage its of the operator of an API gateway to manage its lifecycle. Gateway API gives us an opportunity for using the operator pattern to configure gateways. So this is how it works. So gateway API, gateway class in resemblance of storage class or ingress class is an instruction for potential operator of API gateway instances or proxy instances that instructs it how to deploy individual gateways. And gateway is nothing more, nothing less than a manifest saying that in a declarative fashion, we want a gateway called Kong with a listener on port 80 to exist. A future version of the Kong Ingress Controller will make it possible to manage gateways by means of creating such manifests. So something that we have on the roadmap for the future is that if you create a new gateway resource like this, with a specific name and with specific listeners and possibly other config, then such a gateway, well, technically speaking, an instance of the proxy will be provisioned for you with this desired config. So this, like I said, this is something that is on our roadmap as the managed node. What we support today is the unmanaged node, which I will get into a little bit more detail about later. Yeah, so gateways are associated with routes of various kinds. So what, like I said earlier, when introducing Gateway API, it decouples the language for describing routes and gateways from the specific protocol. Ingress is very specific about being HTTP first. The way it works with Gateway API is that if you have a proxy that supports more protocols like HTTP, TLS tunnels, TCP connections, UDP connections, gRPC, name it. These are represented by different strongly typed resource kinds, such as HTTP in this case. So the first part of this demo is that I'm going to show you how I deploy an HTTP route in a Kubernetes cluster, and Kubernetes, Kong will pick it up and configure an HTTP proxy rule on Kong by means of this. In the second part of this presentation, I'll do something very similar with a UDP route. So as you can see here, the HTTP route is associated with gateways named Kong, so meaning that this specific route will be represented on this gateway called Kong. And this is a many-to-many relationship, meaning that a gateway can handle multiple HTTP routes, and a route can be associated with multiple gateways. And one route being supported by more than one gateway is a significant improvement over the Ingress API, because a common use case for more than one gateway in the cluster is when you have a separate ingress, external and internal proxy, so as to support or handle traffic coming from the inside or from the outside of the zone differently. So there's nothing preventing us from adding more than one parent ref here, which would make the route appear on more than one gateway. And the ruling thing, here is a rule that matches all requests based on the path prefix here. And the rule says that if the traffic matches the set of rules, then it's forwarded to these backends. And this is another improvement of Gateway API over Ingress, because matches and backend specifications were very tightly coupled to path matching in the former case, and services like Kubernetes services, with a capital S in the latter. The design of the API in Gateway API is such that it's possible to natively express matches based on query string parameters, headers, and other things. And like if you want to, if the Kong Ingress Controller decides to implement a new matching type, there's a possibility for using the extension point here to implement more. And the same thing with backends. Like right now, what's supported is plain Kubernetes services, but as service meshes or any other type of backends becomes becomes visible as an important use case. More types of backend refs can be expressed here, so that the HTTP route can natively express that the backend for the route is something different than a plain Kubernetes service. So with that somewhat lengthy introduction, we can get things moving. So maybe before we apply this, let me show you. So this is the request to our proxy. I'll show you that if we make a request to the HTTP path, it will give us a 404 as well. But if we apply this manifest and allow Kik a few seconds to pick it up, we can see that the Ingress controller configured the Kong proxy to proxy the traffic to the HTTP bean service. What we're saying here is the HTML output of the backend service, which is configured by the HTTP route we're seeing here. So we can do something similar with UDP route. So the example for UDP, as opposed to the example with HTTP, uses a different service. In this case, we're going to deploy Core DNS. Core DNS is a very simple cloud-native DNS server. This instance I have here in this example does something very simple. It relays the requests to arbitrary internet domain names into the default resolver that's configured on the pod, and in-cluster traffic gets forwarded to the Kubernetes service discovery mechanism. So we deploy such a Core DNS instance, and what's going to happen next? We have a similar gateway class and gateway definition here. And UDP, so like I said, this is redundant compared to the previous example, but since both examples are standalone, I'm using them verbatim as they exist in the Kubernetes Ingress Controller repository. Like I said, these entries are going to overwrite the entries which I created as part of the previous attempt with HTTP route. So, but that's just a note. And yeah, we have a similar UDP route, which is strongly typed, and UDP route is a type which is defined by Gateway API stack upstream, and it does something very simple. Basically, forwards the UDP traffic on this listener to the service name Core DNS port 57. So maybe before we deploy it, I'll demonstrate how it doesn't work before creating the entry. So I'm going to use dig. So for those who don't know dig, this is a tool that you can use to make raw DNS queries, similar to NSLOOKUP, but on low level. So what this means is we are making a DNS query over UDP about the domain name google.com to the IP address of the Kubernetes service, which is running the Kong proxy. If we do this now, we'll see that the packet has been sent and received by nothing, right? As intended, because Kong has not been configured to proxy the DNS traffic yet. What we do next is we configure Kong by deploying the Gateway API UDP route. We are saying, please forward the traffic, the UDP port 52 traffic on this address to the Core DNS instance, which is running in the cluster. And with some luck, if we hit enter now, we should be able to see that the Core DNS instance, which is being proxied to by Kong, has given us an answer. So to give a quick summary, the demo I have just done shows us how to deploy the Kong Ingress Controller with Gateway API support, and give us an example of an HTTP service and a UDP service running in the cluster, and Kong being a proxy to those services configured by means of Gateway API. Okay, so now that we're done with the demo, I'll return to my slides real quick. Here we are. Yeah. So this is a really quick reiteration of what I said. The Ingress API is a tightly coupled API from the early days of Kubernetes with limited options for extensions. And Gateway API, like one of the goals of Gateway API is to solve the tight coupling problem. Yeah, so like I said, Ingress is HTTP specific, and Gateway API allows for flexibility to describe any protocol you want by means of existing and new possible types of objects. So today the spec allows for TCP, UDP, TLS, and HTTP out of the box. When I'm saying TLS, I mean raw TLS streams, and HTTP also includes HTTPS. There is an ongoing enhancement proposal implementing support for gRPC in the core protocol as well. So we can expect that gRPC will be supported, will be a part of the core standard for Gateway API as well. But like I said, Gateway API makes it possible to support any other protocol by means of just creating a proprietary resource. Yeah, so the other thing I said is that Ingress only, like the API that exists in Kubernetes before Gateway API, only supports services, and Gateway API makes it generic, and any Kubernetes objects that describe, for example, service match objects, such as issue virtual services, for example, can be used as backends, and such an expression will be read in the future by the Kong Ingress Controller, and there will be a possibility to proxy the traffic directly to the object which is being referenced. Yeah, like I said, Ingress rules only match paths, and in order to do matching on headers and things like that, you need some extensions which are more or less convenient to use. With Gateway API, it's possible to express them in a native way. And there is also a big boost for fine-tuning load balancing. So Ingress basically allows you to configure a single service for a backend of a rule and nothing more. Gateway API allows you to perform things like progressive delivery by means of canarying or something like that, virtually out of the box. Yeah, so this is a quick return into the concept of unmanaged and managed gateways, which I briefly mentioned earlier. So like I said, Gateway API allows you to say that you want a gateway to be provisioned with certain listeners. This is a part of the API which is a big step forward, and we, the team behind the Ingress Controller, are actively working on the mechanism that will manage the lifecycle of the gateway and allow us to configure the details of the configuration details of a Kong Gateway instance, such as the listeners being available on. So when we reach managed gateways, it will mean that we'll have implemented the operator pattern for Kong gateways running on Kubernetes. This is an item that we have on our roadmap for future versions of Kubernetes. What we have today is unmanaged gateways, meaning that the gateway class and gateway objects that you create in a cluster with using Gateway API with the Ingress Controller today requires an existing instance of Kong Gateway running in the cluster. This is what our installation methods for Ingress Controller have been doing since ever. We are going to move away from that, and the lifecycle of gateways is going to be managed by the Ingress Controller itself. So you can say that the Ingress Controller will become the operator for Kong Gateway instances in the future. Yeah, so this is a real quick excerpt from the changelog from versions 2.2 and 2.3. Like I said, the highlight of those two versions is the technical preview of Gateway API. In 2.2, which released in February, we introduced the technical preview. So it's the first version with which it's possible to use Gateway API. We've introduced support for unmanaged gateways and basic HTTP route support. 2.3 extended that, including UDP Route, and the future version 2.4 that we are shipping soon is going to expand to the rest of the Gateway API spec that includes TCP route, TLS route, and UDP route. Yeah, and 2.4 will also include weighted load balancing, which I said is a cornerstone for progressive delivery using Gateway API. Yeah, so 2.2 also included configurable Kubernetes API rate limiting, which is an important feature for heavy users of KIK who have lots of resources in the cluster, lots of services, pods, everything, all the resources. because the Ingress controllers can easily generate pressure on the Kubernetes API. And we have identified that heavy duty usage requires fine-tuning of those parameters. So this is possible as of 2.2. We have also shipped a Grafana dashboard in the Grafana dashboard store, grafana.com, whatever that is. I forgot the domain, but the official Grafana dashboard store has the dashboard available. In 2.3, we also improved the security of Kong admin API. So for a word of explanation, the Ingress control, the architecture of Kong Ingress Controller is that when you deploy Kong with as an Ingress controller, 2 pods or 2 components get spun up. Sorry, one of them is the proxy itself, and the other one is the Ingress controller, which works as a Kubernetes controller and configures the proxy by means of a Kong admin API connection. And as of 2.3, this connection is possible to be secured by means of mutual TLS. We have also made a small enhancement in 2.3 for the legacy API, so the Ingress API implementation. We have added support for a proper Ingress class resource, which is a part of the Ingress v1 spec. Going forward, further configuration fields will be added to the Ingress class resource, meaning that even though the Gateway API is the future for API management, we're still working and actively working and expanding the way it's possible to use Ingress APIs with the Kong Ingress controller. And Ingress class will be a container for those configuration settings, which makes sense to express in a declarative fashion on that API, which we can call legacy. Yeah, so like I said, what we have planned for the short or midterm is that we want to graduate the implementation of Gateway API, which I have demonstrated to you, to beta. Right now, like I said, this is a technical preview hidden behind a feature flag, so that somebody who is an early adopter needs to explicitly say that that they're interested in this feature set and providing us feedback. So graduation to beta and then further to GA will mean that we will lift that feature gate. And we are working, like there is heavy concept work being done right now on managed gateways, which I've explained previously to be instances of Kong Gateway, which are spawned, configured, and operated by the Ingress controller. This is our plan for the implementation for the operator pattern for Kong management, and this project will very likely supersede or be complementary to the Kong operator that we have today. So thank you very much for your attention. Myself and Shane are here to answer your questions regarding Kubernetes and Kong Ingress Controller, but not only. Thank you very much.
Thank you very much, Michał. It was a really great presentation. Let's see if we have any questions from the audience.
I have a suggestion. Besides any question on the presentation, of course, great presentation, by the way. Anything else that the community would like to see, right? Or any suggestions as to things that you would like Kong to start working on?
Please feel free to unmute yourself or type in the chat.
So I think I joined in the middle, Siddharth here. Hey, thank you for the presentation. I joined in the middle, so trying to understand the API gateway is probably would be gateway service will be replacing the Ingress controllers or Ingress kind. Is that what I'm hearing? Sorry, I mean, I just trying to find out.
Yes, eventually gateway and the route types that come along with it would be the ultimate replacement for what is now Ingress.
Oh, okay, okay. And this would be backward compatible, right? I mean, the future versions, at least temporarily, would be backward compatible, where even the Ingress controller, I mean, Ingress resource would be supported.
We don't have any specific time frame in which we would get rid of the Ingress API. I imagine that we will, this isn't a promise, but I would imagine we will support it as long as it is not deprecated in Kubernetes.
Okay, okay, thank you.
Mhm.
Let's see, anyone else?
Me again, sorry. I did also see the two-way, I mean, the mutual TLS for the admin API as a future in the future roadmap. Does it mean the like the mutual TLS at the Ingress side, or the at the front end would be enabled? I believe that is that a enterprise feature?
What it means specifically is that there are flags when you start up the kick now that'll allow you to tell it basically configure the MTLS certificates for talking to the Kong admin API, which we treat as basically our data plane. So before, this was all done kind of on localhost over a local socket, but now it's possible to like have the gateway outside of the container and also easily set up MTLS so that that communication is encrypted and authenticated.
Okay, but is it specific to the admin API versus can be used across?
In this case, it's specific to the admin API.
Okay, okay. The service, the admin API service that is exposed would have that, is it?
Yeah, and by default, it's not exposed. Like I said, it's only over localhost, but we are moving towards the future. There's an issue, kick number 721, I think it is. We are moving towards a future where you should be able to have like multiple gateways controlled by a single controller. Historically, it's just been the controller and the gateway have been right next to each other. And so this is just a stepping stone towards that future.
Oh, God, I understand. Thank you.
Thank you for asking all those questions. Let's see if we have any other questions.
Can you run that environment with both the API gateway and the current Ingress controller setup? And do people migrate from one to the other, or can
I'm sorry, I'm not sure I understand the question. You can run the gateway and the controller setup and migrate?
No, I was going to say, when people want to test this out, would they choose to just run API gateway, or could they run that new thing with the current kick setup?
You can run it with the current kick. If you're on the latest release, it's just a feature flag away and you can turn on the gateway support. But to be more specific, the gateway resource in Kubernetes is just a reflection of the gateway that already existed managed by, say, Helm before in the current releases.
Oh, okay.
Anyone else? Any last questions? Thank you, Shane, for answering the questions while Michał is rebooting.
Yeah, no problem. Seriously, if you have any more questions, just pop up. There's no stupid questions. But if you think of one like right at the end also, I mean, we have discussions for like the Ingress controller. We opened up GitHub discussions a few months back. Feel free to drop something in there too. Was somebody talking? Go ahead.
Sure, yeah. So I also, regarding the feature perspective, do we have anything with respect to GraphQL? QL in the open source version, the community perspective?
I do not believe so, no.
Okay.
If you're looking for some very specific feature, it doesn't hurt to throw in a feature request for it, and we can kind of take a look at that. Get
Sure.
that into our PM's hands and kind of mull it over.
Okay, sure. Yeah, I'll do that.
Yeah, please do. We appreciate that.
Let's give it a couple more minutes. See if anyone will ask. And just to add, we're always curious to hear how our community is using our product. So please share with us. Maybe you have an interesting use case you get to present at one of the user calls. So we're always curious to hear how you use our product. So feel free to share with us as well.
Yep, and again, from the engineering side, we have GitHub discussions. We have Kong on Kubernetes Slack. Just a few places where you can get in touch with us kind of informally. Like, you don't have to create an issue if you're just feeling like you just want to ask a simple question. And that stuff is really helpful for us engineers to understand like what kind of problems people are running into and stuff. So don't be afraid to drop something in there, even if it's not all, if it's foggy to you and you feel like the question's kind of weird. Don't worry about it. Just send it in. We'd love to hear from you. Seems like maybe that's a wrap.
Yeah, let's see. Anyone else? One last question? No. I also wanted to let you all know that we launched our external contributor programs. If you do anything cool with our products, please feel free to let us know here, and you can win pretty cool swag depending on what you do. So please check it out. We would love if you contribute and win some awesome prizes. Our next user call will be on May 10th. We hope to see you all there, and thank you for your time today. Thank you, Shane. Thank you, Michał. See you next time.
Thank you, everybody.
Bye-bye.
Yeah, thanks everyone for watching.
Bye.
See you next time.
Thank you.
Thanks, Michał.
Thank you.